Welcome back to another video, and today we're going to be tackling methods of integration, specifically integration by parts. What I first want you guys to realize is that we use integration by parts when we have two functions multiplied against each other that are of different types. So an example here is we have a polynomial function which we can call f of x and a trig function which we can call g of x. But for right now we're just going to be proving how by parts works. So first we're going to take the derivative of this, which we can just use product rule. So f times g prime plus g times f prime, or x cosine x plus sine x times 1. So the integral of this should be equal to this, or x sine x. And we can write this as two different integrals. The integral of x cosine x plus the integral of sine x is equal to x sine x. Subtracting this over to the other side, we get x sine x minus the integral of sine x, which gives us x sine x plus cosine x. And now we can take a look at what the by parts method actually is. It states that the integral of a to b of a function of f times g prime is equal to f times the antiderivative of g, or just g, from a to b, minus the integral of g times the derivative of f. And I'll show you how that kind of works later. But for now, let's recognize some situations where we use by parts. So here we can see we have two functions, however they're both trig, so we'll just use u sub here. We have an exponential and a trig function, so we use by parts here. This one we have exponential and polynomials, but notice that we could just use u sub to get this and get 1/8 out here, so we can use u sub in this one. This one is two polynomials multiplied together, so we can use u sub. This one is a polynomial and a trig, so we'd use by parts. And this one is a little harder to recognize, but we'd have to look at it like ln x times 1. This is a polynomial, and this is a logarithmic function, so we would use by parts. And now I'm going to go through some examples, but first let's take the antiderivative. The antiderivative of 2 cosine x, we can move the integral out, or the constant out, and the antiderivative of cosine x is just x. Here we could use u sub, setting u equal to x squared, du dx equals 2x, so du over 2x equals dx. These would cancel, so we're left with the integral of cosine u du, which is equal to sine of u plus c, and u is x squared. Over here we can see that we have two different functions, so now we can finally use our by parts. So it's f times g minus the integral of g f prime, and we can set g equal to, or g prime equal to cosine x, because remember this is technically f times g prime, where f is equal to 2x. So that means f prime equals 2 and g equals sine x. So now we can plug that into our function. G times f is 2x sine x minus the integral of sine x times 2. So 2x sine x minus 2 times the integral of sine x is 2x sine x plus 2 cosine x plus c. And here we can see another example with the definite integral this time. So we'll say ln of x is equal to f, and remember I said we had to multiply by 1. It would make the most sense to set g prime to 1, since we can easily take the antiderivative of that to be x, and f prime is just 1 over x. So then we have our formula, which is fg minus the integral of g f prime. So f times g is x ln x minus the integral of g times f prime, which is x over x dx. So x ln x minus the integral of 1, which is x ln x minus x at e to 1. Since it's definite, we don't need the plus c. So what we can do is we can plug in e. So e ln e minus e is just equal to e minus e, which is equal to 0 minus 1 ln 1 minus 1. So that's 0 minus 0 minus 1, which is just equal to positive 1. And here we can see that we can use by parts on a graph as well. So we want to find the integral from 0 to 1 of 2x e to the x. We can set f equal to 2x and g prime equal to e to the x, since it's easy to take the antiderivative of that, the f prime being 2. So then we can use our formula for by parts, which is fg minus the integral of g f prime dx, or f times g is 2x e to the x minus the integral of e to the x times 2 at 0 to 1. So we can say 2x e to the x minus 2 times the integral of e to the x is 2x e to the x minus 2 e to the x, since e to the x is just e to the x, and you take the derivative at 1 to 0. So we can say 2 times 1 times e to the 1 minus 2 e to the 1 minus 2 0 e to the 0 minus 2 e to the 0 is equal to 2 overall, and that is the area under the curve from 0 to 1 for that question. Now, when we have sine of negative 1 of x, we have to also use times 1 as a method. So we can set g prime equal to 1. So g would just be x. F is sine negative 1 of x. And then the derivative of sine negative 1 of x is 1 over root 1 minus x squared. So using our formula, gf minus the integral of gf prime dx. So now we can plug our values in. So gf is just x sine negative 1 x minus the integral of x times 1 over root 1 minus x squared dx. So see here, I can see that I'd probably want to use u sub equals 1 minus x squared du over dx equals negative 2x. So I'd take a negative 1/2, get 1 over root the integral of 1 over root u with respect to u. So the integral of u to the negative 1/2 is u to the 1/2 times 2. So I would get negative 1 of x plus 1/2 times 2 root u, which is x sine negative 1 x plus root u. We said u was 1 minus x squared, so we plug that back in and we have our constant of integration. Over here we have a definite integral. So first what I would do is I'd set f equal to 5x g prime equal to e to the negative x, since it's easy to take the antiderivative of that. So g would equal negative e to the negative x, f prime would equal 5. So using my equation, gf minus the integral of gf prime, so g times f is negative 5x e to the negative x minus the integral of negative 5 e to the negative x dx. So we can take our constant of integration out, and we get negative 5x e to the negative x minus 5 e to the negative x at 1 to 0. And then if we plug those numbers in, we get negative 5 times 1 e to the negative 1 is 5 e to the negative 1 minus negative 5 times 0 e to the negative 0 minus 5 e to the negative 0. And you should get a value of 10 over e plus 5 if you do evaluate that. And over here, we can see this is our definition of an integral, kind of. So we know the answer of this is just going to be gf minus the integral of gf prime dx. So our answer is just this. One thing I do want you to note is after this video is I mentioned how I was choosing my f and g prime of x based on how easy it was to take the antiderivative. But there is a rule you should memorize for this, or how to choose f of x. And that rule is called Lipet. So first is log. Whenever you see a log function like ln of x, you immediately want to set f of x to that because it's hard to integrate this. Then we have inverse trig because this is easy to derive but hard to integrate. So f of x equals sine negative 1x. Then we have power. This is a little easier to integrate, but it's still not worth that much time. So like something like x cubed. Then an exponential function. So like 3 to the x. And then we just have trig, so sine x. But that is just integration by parts. Thank you.